That means it must be, everything must be in SI unit. Okay, later I'll elaborate more. I like to talk about this contact pressure because this comes to my mind first.
Not a very good one, but I still don't. Mine better. I don't care. Hydraulic press. Pressure.
Okay, then now we go to liquid pressure. Pressure equals rho G H. This is a SI unit formula. That means if it's given as 84 mm, what do you need to do? If the height is given in 84 mm, convert to meters. If it's given in 84 cm, convert to meters. So what does 84 mm C2P means? Height of liquid C2P is 84 mm. Okay, and
Pressure. I don't know what's phosphorus. Okay.
to use liquid wise density if you want to calculate the pressure. And in this case, if it's 84 mm C2P, it means that 84 mm is the height of the liquid. Now, if it's 84 mm, you need to convert it to meters if you want to calculate in terms of Pascal. And you also need to use the density of the liquid, this fictitious liquid called C2P. Okay? And what is actually missing in this 84 mm C2P? Guys, what is missing in this 84 mm C2P? Gravitational field strength. Sometimes they don't give you, but it is taken, okay, that we are doing things on Earth. So you need to multiply in your G of 10. Don't forget, that is where a lot of students make mistake. In the form of the liquid, you can give it like that. Yeah, but if they want the final answer and they put a unit of Pascal there, you need to multiply your G equals to 10 inside yourself. Okay? So that's for liquid pressure.
Wait, amount of air acting, amount of air above, and area.
Right. It's actually the amount of air. Atmospheric pressure is weighing down on us. It depends on the amount of air. So we have barometer and we also have Andini, okay? I can zoom in. Example, so draw arrows at surfaces subjected to gas pressure. Okay? When there's vacuum, no need to draw because there's no pressure. So at all those surfaces that we have gas pressing down, at the surface between the gas and the liquid, draw a downward arrow. Okay, then next thing is your same liquid, same level, same pressure. How do I know that it's a manometer question when a manometer is drawn? How do I know it's a barometer when it's drawn? How do I know it's a liquid pressure? It can also be found in your barometer. So as long as they give you a height of liquid. Okay, so basically this is pressure. In the video, answer is D. Because the metal block exerts a force of S and the area in contact is Y. Okay, so it must be S over Y. Okay, now question 5. Question 5 is a little bit hard. So inside was P1, then the pressure inside the balloon is P2. So P1 equals to P2 initially. But since I use a vacuum pump, initially. So until it is equal to the new P1. D.
Are you kidding me? That was right.
Yeah. Hey, sorry. Oh no. Will be found in the video. So you don't need to copy down. Later you go back, you do already, then you watch the video. Question 8 answer is D. Now question 9, what's the answer? Okay, if there is no mention of whether it's a good barometer or defective barometer, you can always take it that the barometer is working fine. That means there must be vacuum here. That means for this surface, I do not need to add any arrows. Okay, so now I want the pressure at K. Imagine you are now at K. What is weighing down on you? Vacuum, right? But vacuum is nothing. What else is acting down on you? The height of the liquid above you. So what is the pressure at point K? Will be 90 minus 34 to find the height of the liquid above me. So 56 cm kg. Are you able to convert it to Pascal? What do you need to do? How do I convert 56 cm kg to Pascal? I will need to take 56 divided by 100 to change it to meters because this is SI unit multiplied by G that is not found here. On Earth is 10 multiplied by 13600 kg per meter cube. It may be provided to you. Usually you don't need to memorize the density of the different liquid, but they may give you in terms of 13.6 gram per cm cube. Like I say, I haven't seen the paper. So they may give you the density in gram per cm cube. So do you know how to convert to kg per meter cube? You can go through the math or you can just memorize 13.6 gram per cm cube multiplied by 1000. You get kg per meter cube. So how about water? What's the density?
1000 kg.
Water is 1 gram per cm cube. That means in SI unit it is 1000 kg per meter cube. Okay? So you must be able to convert the liquid pressure in terms of the height and the density to Pascal. Okay? So always take note, you need to convert it to SI unit. Okay, then what's the next one that I want you all to do? Okay, can we do question 15 and 16? 15 and 16. Meanwhile, I'll just write the answers for the other MCQ so you can go back and check your answers. But please do questions 15 and 16, which I'll be going through. Sorry? 15 and 16. Okay, so do question 15 and 16. The trick here is the diameter. Okay, diameter of x is 5, diameter of y is 10. So their difference in diameter is 2 times. Therefore, their difference in area will be 4 times. 4 times. Okay, so answer will be D. Okay, so what they give you is the diameter, right? But the formula is pressure equals to force over area. Pressure is the same throughout this liquid, but because they give you diameter, it is not the same as area. How do you find area? Because we take it as a cylinder. So you have to use area equals to pi r square or pi d over 2 square. Okay? So you'll find that it is not just a factor of 2, it is a factor of 4. So those of you who got it wrong, possibly you chose 24, is it? Yeah, so please take note, you've been warned. This is physics teacher's favorite question. Just now that one, D, okay? It's because it's a factor of 4. Can I do the working? Can, although my battery running out for you. Fx. Ax is pi. Okay, so pi and pi can cancel. So Fy equals to 5 square over 2.5 square times 12. Yes. And to give you all some bonus on indices, 5 over 2.5 whole thing square. Correct? Same power can combine. So 5 over 2.5 is 2. So you see, it is not just a factor of 2. Right? It is a factor of 4. Because your radius and your area, there's a square involved. Okay, Ken? Okay, how about question 16? 16, what is the answer? Did you all draw arrows? Did you all determine same liquid, same level, same pressure? If you did, then your answer should be D. Need me to go through? Need or don't need? Okay, so this is the gas supply. So what I will do here is I will do P gas. Then here must be exposed to atmospheric pressure, so PATM. So this is the difference in the pressure, the height of this water. If I were to calculate using rho GH, that will give me the difference in pressure in Pascal. Now, who has a higher pressure? P gas greater than PATM, right? It is now replaced by cooking oil. That means cooking oil has less dense, right? So, do we still have the same difference in pressure? Okay, but the same difference in pressure is now your rho GH, correct? And now if let's say we use oil, it's still the same difference in pressure. It's also still rho GH, right? So can I say rho GH equals to rho GH? Of course. Rho GH of what? Rho GH of water, height of water equals to rho GH of oil. So G and G can cancel. Yes. And let's make the height together lah. Height over water over height of oil equals to, okay? So because this is smaller than water, so I'm going to get a number that is lesser than 1. That means my height of water must be lesser than height of oil. Okay? Anyone with an easier method?
Yeah.
How?
Okay. Because
Assuming that the no, what's the pressure exerted by the block on the table? Okay lah. So this is the way that I interpret lah. You go and ask